Alright, so in Module 3, Lesson 5, we're going to be talking about the fundamental theorem of similarity again. And I want to start off by restating the fundamental theorem of similarity, and looking at the converse of it. So here we go. I would maybe write this down, put it to memory somehow. The fundamental theorem of similarity states that given a dilation from center O and points P and Q, not collinear, so they're on different lines, the segments formed when P or Q are connected, as well as P prime and Q prime, the lines are parallel. Segment PQ, even though not dilated like P prime and Q prime, dilates to segment P prime Q prime, and the length of the segment P prime Q prime is the length of the segment PQ multiplied by the scale factor. So essentially all that's saying is that when you dilate points and connect the lines, that the lines segments that are made there are also dilated by the scale factor. Okay? The converse of the fundamental theorem of similarity is segment PQ and P prime Q prime are parallel. They have to be parallel. That's very important. And the distance from P prime Q prime equals the scale factor times the distance from P to Q. Then we have a center O. P prime is a dilation of P. Q prime is a dilation of Q. So the distance from O to P prime equals the scale factor times the distance from O to P, and the distance from O to Q prime equals the scale factor times the distance from O to Q. Okay, I would write that down, put it into memory somehow, something there. Okay, and then we're going to jump in here right into exercise 1. Okay, you will need a straight edge for this. Okay, and maybe a calculator for the rest of this stuff. In the diagram below, points P and Q have been dilated from center O by scale factor R. So segment PQ is parallel to segment P prime Q prime. The distance from P to Q equals 5 centimeters, and the distance from P prime to Q prime equals 10 centimeters. So A says determine the scale factor. Okay, so we're just going to use the definition of a dilation to determine the scale factor. So the distance from P prime to Q prime equals the scale factor times the distance from P to Q. The distance from P prime to Q prime was 10 equals our scale factor times the distance from P prime to Q prime, which is 5. We divide both sides by 5. Our scale factor is 2. Okay? B says locate the center of dilation. Measure segments that verify. Oh, you will need a ruler. Sorry. Measure the segments that verify. So to do this, all you're going to do is take your ruler, okay, and you're going to draw a line through P and P prime so that it is extended out, okay, like this. And then we're going to do the same thing with Q. Line it up with Q, just like this. Where the lines intersect, that is your point O. So this right here is our center, and we're going to label it O. Measure the segments to verify that the distance from O to P prime equals the distance from O to P, and the distance from O to Q prime equals the scale factor times O to Q, the distance from O to Q. So, I'm just going to write this out. Do the same thing for O to Q prime. And then I'm just going to do some measurements. So here we go. I'll measure this from P to O, it looks to be about 2.8, maybe 2.9. So if I plug that in and multiply it, 2.8 times our scale factor, which is 2, we get 5.6. So the distance from O to P prime should be 5.6. So let's measure that out. And that does work, 5.6. And then I'm going to do the same thing for O to Q, measure the distance from O to Q, which looks to be about 3.7. And I'm going to multiply that times my scale factor, which is 2. So 3.7 times 2 is 7.4. So when we measure it, the distance from O to Q should be 7.4. And in fact, it is 7.4. Okay. And that would be centimeters because we measured in centimeters. Alright. Moving on to exercise 2. In the diagram below, you're given center O and ray OA. Point A is dilated by a scale factor of 4. Use what you know about the fundamental theorem of similarity to find the location of point A. Okay, so with the fundamental theorem of similarity, we have to have parallel lines. And what happens is when we're on a grid, the vertical lines are parallel and the horizontal lines are parallel. So what I'm going to do is I'm just going to take my highlighter, you can use whatever, and I'm just going to draw a line down to the axis below, just like this, so that I'm looking at a line below it. Okay, and down at the end of that line, I'm going to put a point and I'm going to label it B. Okay, so now I can not B prime, B. So now I'm on the x-axis, so I'm going to look for my x coordinate. Okay, because if I dilate this by the scale factor of 4, I will get my x-coordinate. So the distance, x-coordinate, the distance from O to B prime equals our scale factor times the distance from O to B. Our scale factor is 4. The distance from O to B, we just count along the axis, 1, 2, 3. So the distance from O to B prime will be 12. So over here at 12, I'm going to put a point and I'm going to label it B prime. That's our x coordinate. Because it says find the location of A prime, so our goal is to have a coordinate for A prime. We should have a number here and a number here. You can't see that. Okay, so we should come up with a coordinate for A prime. So now that we have our x coordinate, we're going to use what we know about the fundamental theorem of similarity and look for the y coordinate, exactly where A is. Now we can do this two ways, but when it asks for the precise location of A prime, you're going to have to work through this. So the first way you can do it is to verify is just because this is parallel, we have to draw a line parallel to it with B prime as the endpoint. So we can just take this and draw it straight up or straight down. And A prime will be located right here. So because this one is a nice easy one, we can easily see that it's located at 12. But I'm going to show you how to work through this so you get it correctly. So the y coordinate we're going to use this line here, this line here, the actual lines that are parallel now. So the distance from A prime to B prime equals our scale factor times the distance from A to B. So our scale factor is 4. And the distance from A to B, you're just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, sorry. 1, 2, 3. A to B, scratch that. It would be 4 times the distance from A to B is 1, 2, 3. So then we get 12. So our coordinate for A prime, the x value goes first, would be 12. And then the y value goes second, would be 12. Okay. This is really messed up there. Alright. We're going to do some more examples of this. Exercise 3. In the diagram below, you're given center O and ray OA. Point A is dilated by a scale factor of r equals 5/12. Use what you know about the fundamental theorem of similarity to locate the point of A prime. So essentially, same thing again. We want to know the coordinate of A prime. So we have to do a little work. And this time it's not going to be quite as easy because the scale factor is a fraction. Okay, so we're going to work through this. So first thing I'm going to do is because fundamental theorem of similarity needs parallel lines, I'm just going to draw straight down like this. Okay, down here, I'm going to put B prime. Now, or not B prime, I don't know why I keep doing it, B. Now we need to find where B prime would be located using the distance from O to B and the scale factor. And I'm looking at this because B is on the x-axis. That's why it's the x coordinate. Okay. So the distance from O to B prime would be would equal the scale factor times the distance from O to B. So our scale factor is 5/12 times the distance from O to B, which is 12. Now, we can simplify this first. We put this over 1. These two cancel, and we're left with the distance from O to B is 5. Okay, so at 5, I'm going to put a point, and that would be B prime. The distance from O to B prime is 5. Then you can draw straight up on the vertical line, and that is where A prime will be located. And this time it's not right on the line, so this is why we have to go through these steps to find out what it is. Okay, and since now we're going up to find this location, when we go up, that's the y coordinate, so now we have to find the y coordinate. Okay, and when we're going up, we're looking at the parallel lines. So that's why here I'm going to go the distance from A prime to B prime, because that's one of my parallel lines, equals the scale factor times the distance from A to B, my other parallel line. So 5/12 times the distance from A to B. Now this is where I count this. 1, 2, 3, 4, 5, 6, 7, 8. 8. Now, I'm going to put this over 1, and I'm going to simplify. Actually, no I'm not. I'm just going to multiply. So this would be 40, 5 times 8 over 12. So, our exact location for this, okay, our x coordinate, which is the first number, would be 5. And our y coordinate, which is the second number in the coordinate pair, would be 40 over 12. Okay? And the lesson summary. Okay, so the converse of the fundamental theorem or search for similarity, I can't talk today, is right here. Okay, we already wrote that down. And to find coordinates of a dilated point, you got to use what we know about the fundamental theorem of similarity. Okay, you got to remember it's parallel. You got to remember the scale dilation, how to do the definition of a dilation, which is the distance from O to P prime equals the scale factor times the distance from O to P, or whatever the point is, and then the scale factor, which is always R. Okay, so you want to make sure that you have all of those things, you keep all those things in mind when doing when finding a location of a point.